Hi, this is Krista Ritter, and I'm going to dissect my cow eyeball today. Okay, so here we have the cow eyeball, and we see all of the fat and muscle surrounding the eye, and this is what sits inside the orbit of the skull, and it just helps protect the eye from any injuries or in a human eye, like if someone gets hit. It's just like a buffer to protect the eye. We're going to trim all that fat away from the eyeball. It's kind of hard. Oh, I think right here I don't know if you can see right there, this section right here, I think that's the optic nerve. So that means I can still trim around it. Hopefully I don't cut it off. And the optic nerve is what takes essentially the light and the messages basically that comes through the eye and sends that information to the brain so the brain can process what we're seeing, creating our vision. So cows have 4 muscles. Here's the top one, the superior. Humans have 6 muscles. So here's the inferior muscle, the bottom of the eye. Humans have 6 eye muscles that help us rotate our eyes inside of our head, whereas cows can only move sideways and up and down. Humans can move all around with those 2 extra muscles that help us. So yeah, that is the optic nerve right here. It comes out from behind the eye, so it's attached inside of the eye. It attaches to the retina, and then it travels back to the brain. So this white area right here, the white part of the eye that we see, the outermost part, the white part, that's the sclera, and it just protects that outer eye. So it's the outer covering of the eyeball. In front right here, this clear area, that is called the cornea. It's a thin protective layer in front of the eye that light passes through. It's thin, but it actually is 5 layers deep. So now what I'm going to do is just punch a hole so we can see the fluid that comes out of there. So the fluid, if I can get to it, that's in here is called the aqueous humor. And this fluid helps the cornea keep its round shape, and it also nourishes the anterior part of the eye. There we go. So that's the aqueous humor. There it is. So you can see without it, the eye doesn't have that round shape in the front. Kind of deflates. So now I'm going to try and cut around the eye. Oh, I think I got it. So I'm just going to go around the eye. to take the cornea out and the pupil. And I'm just letting everything gush out now. There we go. So remember that liquid that was inside that gave the cornea its shape, the aqueous humor. There's also liquid inside of the eye. It's like a clear jelly-like liquid that helps give it the eye its round shape. It helps keep the round shape right here. This is the vitreous humor. It's thick, clear, jelly-like, and like I said, it gives the eyeball its shape. So we can see here, here's the outside, the cornea, the black part around. Let me see if I can do this. Here we go. So this part of the eye right here, this is the iris, and the hole in the middle of the iris is the pupil. So the iris, its job, what it does is, depending on how much light is hitting the eye, it'll either close up or open or dilate bigger. So if it's dark, the eye will dilate, and if there's a lot of sun, it'll get smaller. And that's how light travels through into the eye, right here, the pupil, and around here, the iris. The iris in humans can be different colors: brown, blue, green. In cows, it's just this dark brown color right here. So right behind the iris, so we have the cornea, the iris, the pupil. Right behind, sitting behind, is the lens, which I have here in my hand. Let me try to do this. So the lens is it's flexible, and it helps the image get to the back of the eye, to the retina. And what's really cool about the lens is that it'll change its shape depending on if it's looking at something close or far away, and that changing shape process is called accommodation. So it accommodates at what it's looking at, either an object far away or close up. So here we have the back of the eye, and this is the retina. And the retina is full of photoreceptor cells that help distinguish what we see. So it's full of rods and cones. And the cones help see color, and the rods help like our peripheral vision. And then our blind spot, known as the optic disc in the retina, is where the optic nerve is connected to the retina. So in this area, there are no photoreceptor cells. We can't really tell, that we have a blind spot. But since there's no cells in that area, no light goes to that area of the inner eye, causing our blind spot. So behind the retina, so if you can see right here, that little hole, I don't know if you can see it. But you can probably see the optic disc back there. There is the optic nerve that connects to the back of the eye, the retina. And so light travels from the cornea through the pupil, the iris, to the lens, to the back of the eye, the retina, and then out through the optic nerve to the brain. So right here, we can see the sclera, the white part, the retina in the inner eye. And then cows have this layer inside that you can see right here that reflects light out, which is kind of cool. It's like cat eyes that reflect at night. Cow eyes do the same thing. That's the layer between the retina and the back of the eye. Humans don't have this. The layer between the sclera and the retina for humans is called the choroid. I believe that's how you say it. It supplies the retina with most of its nutrients. So right here, again, this is our blind spot right there. The optic disc is where the optic nerve connects to the retina. And that's it. I'm gonna clean up. I think I got all the parts of the eye in.